it's Viviane Shwaikani. I'll be explaining part 4 of chapter 9, alcohols. Let's start with the objectives. In this lesson, there is one objective which is about to recognize the conditions and the results in the process of mild oxidation of alcohols following either the dehydrogenation method or the catalytic oxidation. So let's start first of all with a recall from the previous chapters. Alcohols, we know that alcohols can undergo mild oxidation, which doesn't break down the carbon chain. So upon mild oxidation, only the functional group is concerned. We saw also that alcohols, mild oxidation can occur in 3 ways. The first one is the oxidation with strong oxidants such as dichromate and permanganate. This method was studied in details in the previous chapter. Today, we have to study this method and the following one, the catalytic oxidation in the presence of oxygen gas, and the third method, which is the catalytic dehydrogenation in the absence of oxygen gas. We saw also that the product of mild oxidation depends on the class of alcohol. So a primary alcohol upon mild oxidation will give aldehyde and carboxylic acid, and if the mild oxidation is continuous, we will obtain only carboxylic acid at the end. Why? A secondary alcohol upon mild oxidation will give a ketone. What about tertiary alcohols? Tertiary alcohols do not undergo mild oxidation. So now let's start with our first objective, which is about catalytic oxidation of alcohol in the presence of oxygen. Why it is called catalytic? Okay, we have to see. To perform catalytic oxidation, we need an experimental setup as following. Look here. Here is a copper wire, because copper will serve as catalysts, and this is why we said that it's a catalytic oxidation, because there is a catalyst here, which is wire. Here we have an Erlenmeyer or a flask simply containing alcohol. This Erlenmeyer is put in a hot water bath in order for alcohol to vaporize. So here, look what we have. Upon heating alcohol, it vaporizes. So the vapor of alcohols reacts with oxygen molecules in air in the presence of a catalyst such as copper. So as I said here, alcohol is heated, the vapor goes out. Here there is a contact with oxygen coming from air. So this alcohol reacts with oxygen and the oxidation occurs. Actually, this experimental setup is called the flameless lamp. Why? Since the reaction between alcohol and oxygen is exothermic. So the heat released from this reaction will heat this copper wire that will shine. This is why we call it the flameless lamp, as if it's a lamp. Actually, you're not responsible for this. It means in the official exam, you will not be asked about drawing such experimental setup. But since the term flameless lamp is mentioned in your book, this is why we saw that it's important to explain just the setup of this experiment. But again, our concern is the catalytic oxidation of alcohol in the presence of oxygen, to show you what does that mean in the presence of oxygen. With the same objective, catalytic oxidation of alcohols in the presence of oxygen, let's start with primary alcohols. We know that the mild oxidation of a primary alcohol produces aldehyde first and then carboxylic acid. So look at this reaction. That has to be the equation of the reaction. It means that has to be memorized by heart. Here is the primary alcohol in the presence of oxygen. Because it's a balanced one, we have half oxygen. In the presence of copper as a catalyst, what do we obtain here? An aldehyde and H2O. Okay, so as I said, this is to be memorized by heart. Now here there is a remark to be given. As you can notice, for aldehyde it is written RCHO. It is wrong to write it RCOH, because OH is something related to hydroxyl group that is here for alcohol. So even in the molecular formula, you have to respect the order of hydrogen and oxygen when writing it. So I repeat, for an aldehyde it is RCHO and not OH. OH will be considered as wrong. Again, this is my primary alcohol, and this is the aldehyde got, and pay attention here to half O2 and to H2O. As I said, this is to be memorized by heart. Now, the aldehyde obtained here can also undergo oxidation, because as we said, it is in contact with oxygen in air, so there is unlimited amount of oxygen, so definitely the oxidation here can be continuous, and carboxylic acid, as you can see, COOH, is obtained. We can write here the overall equation that will be in the following. Here is a copy of this one, and here is the copy of this one. What do we have to do? We have to add them. How? By canceling this part, so we will obtain as the global or the overall equation that a primary alcohol plus 1 O2 in the presence of copper as a catalyst will give me directly carboxylic acid and H2O. What about, or here is an example of oxidation of ethanol. As you can see, this is ethanol, it's a primary alcohol, and this is the functional group, and it will give me what? Aldehyde. Again, aldehyde, it is CHO. Notice here that the main carbon chain doesn't change, it stays intact, because what? Because catalytic oxidation is a mild oxidation, so only, as you can see, the functional group here is concerned, while the carbon here stays the same. And this is ethanol, that in the presence of oxygen will continue to produce carboxylic acid, which is ethanoic acid. Okay, can you see here? This is aldehyde and this is carboxylic acid. Directly, you can write the overall equation by adding these two, as we did in the previous slide. Here is the primary alcohol, and here is the carboxylic acid obtained. Now, as you can see, here are the functional groups. Now, let's move to secondary alcohol, the catalytic oxidation for secondary alcohols. We know that the catalytic oxidation, since it's a mild oxidation of secondary alcohols, will produce ketones only. Here is the general equation. As you can see, here is the secondary alcohol because we have two alkyl groups in it, plus half O2 in the presence of copper as a catalyst. What do we obtain? The ketone. Again, look at the carbon chain. It was RCR prime. It is always RCR prime because it is a mild oxidation, so the carbon chain stays intact, plus H2O. Here also this reaction is to be, this equation, sorry, is to be memorized by heart. Let's consider this example, that of 2-propanol. Look, here is 2-propanol. As you can see, it would give me propanol. The second or the third method of mild oxidation is the catalytic dehydrogenation. Now, why dehydrogenation? It's a mild oxidation because mild oxidation can be done upon adding oxygen or upon taking hydrogen from the substance. So when we take hydrogen from the compound, as if we are doing oxidation. So keep this in mind. A dehydrogenation is actually an oxidation in organic. The catalytic dehydrogenation, here it has to be dehydrogenation, not hydrogenation. The catalytic dehydrogenation of alcohols is a mild oxidation, so the product depends also on the class of alcohol. The primary alcohol, the catalytic dehydrogenation of a primary alcohol produces only aldehyde. Okay, pay attention. The catalytic dehydrogenation, I repeat, here is a mistake, of primary alcohol produces only aldehyde. Can you see? So it doesn't produce amine carboxylic acid, specifically exclusively aldehyde. So the conditions is the presence of a catalyst and heating. These not to be memorized, these conditions, but the equation is to be memorized by heart. So pay attention that the catalytic dehydrogenation of a primary alcohol produces only aldehyde without producing at all carboxylic acid. It means there is no continuous mild oxidation in this type of reaction. The catalytic dehydrogenation of a secondary alcohol, as you can see here, catalytic dehydrogenation of a secondary alcohol produces only a ketone. This is our secondary alcohol, and this is the ketone that is produced. Okay, let's consider also here an example. Here is a branched alcohol. Can you see? This is the functional group OH, and this is the carbonyl group of ketones. As an application, you have to consider the following alcohol. There are three instructions to be done. Do a pause for the video and work it on a scratch paper. Now check your answers. Here are the answers. As a summary, we saw that the catalytic oxidation of alcohols is a mild oxidation in the presence of oxygen. The catalytic oxidation of primary alcohols gives two products, aldehyde and carboxylic acid. The catalytic oxidation of secondary alcohols produces ketone, and the catalytic dehydrogenation occurs in the absence of oxygen, because if oxygen is present, we will turn to have this reaction. The catalytic dehydrogenation of primary alcohols produces only aldehydes without producing carboxylic acid. The catalytic dehydrogenation of secondary alcohols produces ketones, and again, tertiary alcohols do not undergo mild oxidation. Now, this is your agenda. Do a pause and do what is required, and I will thank you, and I'll see you in another video. Thanks.